All right, so moving right along with propositional logic, I want to talk about the other two connectives, the other two little symbols that Smith has introduced so far. And they are our little wedge symbol, which I actually think in every single logic book I've ever seen, this is the one they use for OR, is the wedge, which is really kind of amazing. And this little tilde, up in the far left-hand corner of your keyboard, I would think, or the sort of, rotated little L figure. Look, he uses the little L. It's hard to find. You have to dig into like math symbols, or you have to do like the little alt, whatever. I'm not going to use it. It's hard to find on a keyboard. He does. I'm going to use the tilde because it's easier, and you'll see this used in a lot of logic books, I think, for exactly that reason. So let's start talking about OR. And one thing to notice about the wedge or OR, and when this has already come up, when we were talking about, in the exercises, the Stoic conceptional logic, is there's two different senses of OR. There's two different ways we might use OR in English, or I think most other languages, right? Definitely two ways we might use OR in logic. First, there's the exclusive OR. What do I mean by an exclusive OR? Well, we have either A or B, and one is true, but not both. Either the Democrat or the Republican will win the White House. One will win, one will lose, right? You might hear, maybe the U.S. is the team is in the finals for some event. I don't know how a lot of this works. I don't follow the Olympics too closely since they dropped baseball, but whatever. We find out that the U.S. soccer team is in the finals and they got to play one more game and they're either going to win silver or gold, right? There's no case where they win both silver and gold. If they won gold, they didn't win silver, and if they won silver, they didn't win gold. They will win one or the other. You order some meal at a restaurant and it comes with soup or salad. You don't say, well, could I have both? You get one or the other. You have to make a choice, the soup or the salad, right? But there is also this inclusive sense of OR. At least one of two statements is true, and both may be true. Go to the doctor and she says, to get your blood pressure under control, you need to reduce your stress or lose weight. Well, you wouldn't go back to the doctor. You go back and she says, well, which of those did you do? And you say, well, I lost some weight and I changed jobs for one that's way more stressful. She wouldn't be, I said one or the other. Clearly, she means you need to do at least one of these. It might be a good idea to do both, right? You have a crying baby. Trust me, from much, much experience, I know, if a baby is crying, there are two main causes. He's either poopy or hungry. But, and this crushes every new parent's soul, the baby can be both, right? You might change his poopy diaper, and he keeps sobbing. He is also hungry, right? You might feed him, and the second he's done, he might toss the bottle and pick right back up sobbing. He might also be poopy. He's one or the other, but because the world is such a fun and wonderful place, he could be both, right? If your friend says, well, I think a good class is easy or interesting, you wouldn't only tell him or her about classes you thought were easy but boring, or interesting but hard. You would say, well, it has to be one of these, but it could be both, right? The V is an inclusive OR. The V says at least one of these statements is true, but they might both be. Now we'll talk about a lot of times you don't even really need the inclusive or the exclusive or, but we'll talk about how you can get it if you want it, right? Or if you need. Well, if the V is an inclusive or, what are its truth conditions going to be? When is it going to be true? If we put two letters on each side of it, and the letters stand for different statements, when is our little statement with the V, the whole formula, going to be true? When is it going to have a T or a 1 pop out on the old truth table? Well, anytime that either statement is true, it's going to be true, right? In fact, the only time that our inclusive or is going to be false is when both A and B are false, right? Again, already, like I said, if you do computers or electrical engineering, things like that, you're probably already starting to see how this hooks up with some other stuff. But again, you know, think about our A's and B's. Our our T's can be a 1 or they can be an on. Our F's are a 0 or an off. Well, anytime A or B is a 1 or it's on, this A or B is on or it gives you a 1, right? It's only when both A and B are false, they're both zeros, they're both off, that our A or B gives you an F or it gives you a 0 or it's off, right? Finally, our not symbol. Now, this one is actually often pretty tricky. Like negation can be pretty tricky. A lot of times if you do practice this, you'll see like just kind of easier, more elegant ways to do this. But when you're first starting out, a lot of times to just be careful with this, you might just treat the little tilde symbol as saying, it is not true that, and just plop that in front of whatever the statement with the letter is. Jimmy Carter was governor of Florida, not F, tilde F equals, it is not true that Jimmy Carter was governor of Florida. Now again, we'll practice more with these. This is kind of a mouthful. It's not very pretty English. As we get better at this, we can translate this a little more elegantly, a little more nicely. But for the time being, especially if you're having some trouble with this kind of more flat-footed, very literal way might be the best way to think about it. Well, what's the truth value for the tilde going to be? Well, basically, it's just going to flip the value of whatever it's in front of. When A is true, tilde not A is false. When A is false, tilde not A is true. The not symbol just flips things. Now, one thing to note, and we'll see this a lot, and you can combine these and we'll see this more in the next lecture, is that our little tilde symbol can go in front of a whole formula. It doesn't just go, it can go in front of a letter, it can also go in front of a whole formula. When it does that, it flips the truth value of the whole formula. So remember, A and B is false except when A and B are both true. Every other time it's false. Well, not A and B is going to have exactly the mirror image, right? It's going to be, the tilde here is going to be false only when A and B is true. That's when A and B are both true on the truth table. Every other line it's going to be true because it's flipping the value of this A and B statement. Not A or B. Well, A or B is true on every line except when they're both false. But when we put the tilde in front of it, it's false on every single one except the last one, right? So it just flips the value of the whole formula. That's one way to think of this. Look and see what the truth value of the whole formula is, then look at your tilde, and the tilde flips it, right?